Thank you for sending the question about mutually exclusive or not mutually exclusive events and finding the probability of A and B, as well as finding the probability of A or B. To start with, let's talk through what it means to be mutually exclusive. When two events are mutually exclusive, that's going to mean that they cannot happen together. So let me write that in. Mutually exclusive events can't happen together or at the same time. Here's an example. There we go. Can't happen. Sorry, that's a little bit messy. Let me try and write that a little more clearly. So if you're saving this, you can read it really well. Can't happen at the same time. Here's an example of two events that are mutually exclusive. If you were to draw a card from a standard deck of cards, the event of having a heart, drawing a heart, and the event of drawing, let's say, a club, those are mutually exclusive. You can't get a card that's a heart and a club at the same time. Now let's look at two events that are not mutually exclusive. Let's say drawing a 3 and drawing a club. There is a card in that deck, unless your little brother's gotten a hold of that deck and lost some cards, right? But if it's a standard deck of cards that has not been tampered with, there is a card in there that is both a 3 and a club. We'd call that the 3 of clubs. So that's mutually exclusive. Let's look at the example of finding the probability of getting a card that's both a 3 and a club, or whatever the different case might be. So let's find the probability of getting both event A to occur and event B to occur. So that's the probability of A intersection B, and that symbol like an upside down U, or a capital A without the line through it. That's an intersection, and it means and. The probability of A and B is the probability of A times the probability of B. So in this case, 10% changed to a decimal, 0.10, 20% changed to a decimal, 0.20. If I multiplied those together, I'd get a 2 with, well, let me drop these zeros to make sure you're understanding the arithmetic here. You could put this in on a calculator. 1 times 2 is 2, and then I need 2 decimal places. So to get 2 decimal places, I'll have to insert placeholder 0. But it looks like the probability of both events happening, so event A and event B, is only 2 out of 100, 2/100ths, or just this very, very small chance of 2%. On the other hand, what's the probability of them both, I'm not sorry, not both, of either or happening? So of event A or event B. And this is a union, and its symbol is like a U for union. But when we see this symbol that looks like a U, the union symbol, it means or. And that's the probability of A plus the probability of B. But then we have to subtract out those double counts, the probability up above of both of them happening at the same time if they're not mutually exclusive. Now, by the way, if the two events are mutually exclusive, then the probability of them happening together would have been 0. But in this case, the problem said that they're not mutually exclusive, so we're going to add the probability of A plus the probability of B, so that gives us 0.3, and then we're going to subtract the probability of both of them occurring together, 38 minus 2 is 28, or I'm sorry, 30 minus 2 is 28. So 30% minus 2% is 28%. There's a 28% chance for either A or B to happen. I hope that this helps you with that question on your quiz. Thanks so much for doing that rework and putting so much good time into your work.